Good morning, ladies and gentlemen. Seán Finan is my name. I'm the CEO of the Irish Bioenergy Association, and I'm delighted to welcome you this morning to our IrBEA Bioenergy webinar series and webinar number 48. This morning we focus on farm-scale biogas production, and we showcase a number of UK technology providers and their innovative solutions. This morning's webinar has been organised in partnership with the British Embassy Dublin. So just by way of introduction, before we go into the slides and our speakers and presenters, our topic is farm-scale biogas production. From the Irish Bioenergy's perspective, we see a role for biogas and biomethane production at all scales. And you would be all familiar that the biomethane strategy was published by the Irish government last year. While that focuses on the medium to large scale industry, there's also a huge opportunity in Ireland for the development of a farm scale biogas industry. However, the support requirements, the types and variety of feedstocks, and the regulatory regime are different depending on the scales of biogas and biomethane production. The animal byproducts regulations are the regulatory regime I refer to, and depending on the size and scale of the facility, the requirements vary. For a farm scale biogas plant, I suppose the principle is that the farmer would operate the plant and it would complement the existing farm enterprise, and the energy would be used by and large on the farm. And generally, the technology of choice is combined heat and power, where electricity is produced to offset the electricity demand on the farm, and also the heat is used to offset a fossil heating bill, but also potentially to heat the biogas facility or plant itself. So they're just some high-level points. So by way of introduction, this morning we will have a few words from David from the British Embassy Dublin. We will get a very brief update from Noel Gavigan on the work of the Irish Bioenergy Association in the Small Biogas Demonstration project. We will then hear from our two presenters this morning, Biofactory Energy and Cube Renewables, and then we will have a short panel discussion followed by a Q&A session. So feel free to submit your questions via the Q&A tab at the bottom of the screen, and we'd be happy to answer your questions later on. The webinar this morning will run for 1 hour and 15 minutes, slightly longer than our usual 1 hour session, just because we have two presenters this morning compared to our usual one. So the Irish Bioenergy Association were established in 1999. We're the representative body for the bioenergy sector, and our membership spans biomass, biogas, biomethane, liquid biofuels, biochar, and quite a growing wood fuel membership, and also some people involved in the energy crop sector. As a representative body, our main role is to work on policy, lobby, advocate, and also transfer knowledge to the various different stakeholders within the sector. And our membership is broad and diverse and can range from anything from farmers, foresters, to technology providers, financial institutions, and many other energy users and everyone else that has an interest in the bioenergy space. We also roll out a number of research and development projects, and further information can be found on our website. We also have a fact sheet series. If you'd like to consult our fact sheets, some very valuable information on those. They're available on our website. And this webinar series is growing. If anyone is interested in participating in the webinar series, feel free to get in touch with us. And we're now building our schedule for the remainder of 2025. So this morning's speakers, we'll hear first from David IrBEA, Senior Trade and Communications Officer with the British Embassy in Dublin. And we're delighted to partner with David and the Embassy for this webinar. We will then hear from Owen Sharkey, CEO and Head of Engineering at Biofactory Energy. We will then hear from James Rundle, who's the Head of Sales at Cube Renewables, and we'll also hear from Noel Gavigan, who is our Technical Executive at the Irish Bioenergy Association. So we're currently planning our future webinars. So number 49 will take place in the next few weeks, Wednesday morning slot, 9:30 to 10:30. Next topic is to be confirmed. But if you are interested in presenting on a topic, either a project, a service, a product, please get in touch as we're building our program for the remainder of 2025. It gives me a great pleasure to now introduce David. David is a Senior Trade and Communications Officer at the British Embassy in Dublin. where he leads on the bioenergy, including biomethane and water infrastructure, by keeping watching brief on both solar and hydrogen. He helps UK companies connect with Irish commercial opportunities and manages the communications across the Embassy's trade team. Prior to joining the Embassy, Dave worked at IBEC across the tech, food and health sectors, giving him a strong understanding of Irish industry priorities. He brings a collaborative focus, commercial grounded approach to advancing clean energy collaboration between the UK and Ireland. So David, over to you to say a few words, and thanks very much for partnering with us this morning.
Thanks, Seán. Good morning, everyone, and thanks again for joining. So I won't introduce myself again. Thanks, Seán, for that lovely intro. It's a real pleasure to partner with IrBEA today on this session, and just want to thank Seán and the team for their collaboration. I think we're joined today by stakeholders from across government, energy, policy, and more, from Ireland and from further afield, and I think that reflects the cross-border and cross-sector importance of this issue. So Seán mentioned this forms part of the broader bioenergy series from IrBEA, and we're focusing today on farm-scale biogas production and practical modular technologies that can help to enable it. The IrBEA Small Biogas Demonstration project, funded by the Department of Agriculture, has shown that small-scale AD can work in the Irish context, and Noel will speak about that after me. So earlier this year, the British and Irish governments signed the UK-Ireland 2030 joint statement, which reaffirms strategic cooperation across clean energy, infrastructure, and climate. It highlighted some shared priorities around energy security, decarbonisation, and rural resilience, which are areas where farm-based AD can clearly fit. And while biomethane and AD are not named directly in that statement, it's exactly the kind of solution that the statement points to: locally driven, technically viable, and aligned with wider climate goals. And this conversation here also takes place at a wider moment of renewed cooperation between the UK and the EU, and between the UK and Ireland. We've seen a reset in terms of both tone and intent, with both sides focused on sustainable growth, energy resilience, and economic opportunity. Clean infrastructure, particularly in areas like AD, but also wider in terms of offshore wind and hydrogen, is one of the most productive spaces for that cooperation to take shape. That said, there's also an awareness that the AD biomethane sector is under strain here in Ireland, as Seán mentioned, from market uncertainty, the dominance of some cheaper imported biofuels, and some recent high-profile challenges for domestic producers. And these are serious issues. They can undermine confidence, limit investment, and risk sending the wrong signals to the very communities that are being asked to lead this transition. I've also seen recent public calls, notably from the Irish Farmers Association, for a full review of the policy and a clearer framework to underpin the rollout of AD in Ireland. And I think that's a reminder that real delivery doesn't just rely on capital funding. It requires market structure, long-term certainty, and joined-up policy thinking across departments. And these are conversations that the UK is familiar with also. And that's where I believe practical international collaboration can help. Offer tested models, lessons from the field, and realistic technology options that land quickly and can deliver value. So in the UK, there have been policy setbacks, but it has also been shown how modular farm-based AD systems, deployed with clear planning processes and supported with the right commercial structures, can deliver energy, value, and jobs in rural communities. And I think there's something very useful in that experience. I should say up front that I'm not technical or a policy expert, but I do work with those people who are. My role, as Seán said, is to help build connections, open doors, and support the cross-border collaboration that can turn good ideas into real-world delivery. And that's where today's session comes in. Now, this is not about selling, it's about sharing. The UK companies here, Cube, Renewables, and Biofactory, bring practical, tested technologies designed for farm-scale deployment. They've delivered dozens of systems across the UK and internationally, and they've done so in a policy environment that hasn't always been easy. And while the two companies are speaking here today, I also want to note that I think several other UK companies in the sector are in attendance. And that, I believe, reflects a growing interest in the Irish market and a broader readiness to engage where there's alignment. Beyond that, I've also worked with a number of UK firms who are not present today, but who are looking closely at Ireland as a market where innovation can land if the conditions are right. And while today is a starting point, it's not intended to be a one-off, in my opinion. So I'd like this engagement to continue, whether that's in the form of roundtables, joint visits, or conversations about projects, things that can really help turn ideas into delivery. Because the opportunity is real, so are the challenges, but it's only through practical, policy-aware collaboration that we can close that gap. So thanks again for being here, and I really hope that today sparks some useful ideas, builds some new connections, and builds the kind of momentum that this sector needs and deserves. And with that, I hand over to Noel.
Thanks, David. Yeah, Noel, over to you.
No. Thanks, Seán. I'm not sure if the video will work there, but let's just try it out there. So if you want to
hear you anyways, Noel, yeah.
Okay, that's fine. Yeah, so basically the program which we ran for 5 years, a small scale demonstration project, we've received funding through the EIP, and effectively it allowed us to survey a large number of farms across Ireland, which had volunteered for a survey, and to see which would be suitable for building demonstration plants. And we also had the ability to provide 50% capital funding for a small number of plants. Now, these were, we call their Type 9 plant, which is a designation under animal byproducts rules. Basically, what that means is it is only taking material from the farm. It may take farmyard manure, slurry, or any other animal byproduct that's produced on the farm or the farm's own crop material. It does not take in any imported material. It's strictly limited to the farm use. And really what it is, this is looking at it becoming a tool on the farm to aid nutrient management, as well as energy generation. So it's not a standalone plant. Farm will still continue to do whatever it does, whether it's a dairy, pig, whatever it happens to, whatever the enterprise is, will continue. This is just a tool to supplement that. It allows the recycling of nutrients and lots of other benefits from that as well. What's interesting in this is one of the big case studies that we used was a review done by the Royal Agricultural Society of England, which you might find, or other presenters might find interesting, written by Angela Bywater. And there was some excellent examples of UK farms on that, plants that were built exactly what we were looking at. These were all built in the 70s and 80s and 90s, literally built to service the farm itself. And that report we found very useful throughout the process, including the initial design of this whole project. So if you want to go on to the next slide there, Seán. So what we have advanced on this is we did assess a large number of farms. We eventually whittled it down to 7 and to 3, which we offered to look at building plants on. We further advanced 2 of those. One decided that for various operational reasons not to go ahead at this point in time. So we have one plant built on an organic dairy farm in Galway. It's a 200 cow herd. It's got robotic milking. The cows are in at night during the summer due to land restrictions, and they're in all winter. So there's a relatively good steady supply of slurry. The total cost of that was around 450,000. We supplied 50% grant funding, and it's the plant is under commissioning at the moment. It's a couple of things to sort out before it gets AVP, but I mean it's getting ready to roll. So it's we reckon that the payback on that will be about 7 years, going by the savings on electricity, and there'll be some export of electricity as well. And there's other benefits that we have done some work to try and determine the value of, in terms of the financial value of making the nutrients more available. And that's very important in organic farms because it's all about recycling nutrients. Indeed, on that initial RAISE report, you see that most of the original digesters going on farms were on organic farms, and they done it more for nutrient management rather than actually energy production. So this really complements this farm in terms of recycling the NP and K, making it a lot more available to the plant and a lot more instantly available. So we've seen the benefits of that on other farms. And effectively, that plant, we hope to actually run an open day on that sometime in the relatively near future. So I suppose that probably summarizes that project for now. Seán, if you want to go back to I know we're on schedule there.
Yeah, thanks very much, Noel. And again, as Noel said, further information is available on this project if you want to send us an email. or we are available to talk to anyone that wants to talk further about what we have found through the project. We will be publishing the final project report in the coming weeks, and also, as Noel said, we will be doing the open day at the Galway farm in the coming months as well. And just there was a conference about this scale of production back late last November, and the recordings from that are up on our YouTube channel. There's also, we've done webinars detailing the work of this project back through our webinar series, and you can look at them through the our YouTube channel as well. So we move on. Thanks very much, Noel, for your presentation. So our next presenter is Owen Sharkey. Owen is from Biofactory Energy. Biofactory Energy have reinvented anaerobic digestion for dairy farming, specialized in the use of AD technology for microscale and eliminating the barriers to entry by producing cost-effective on-site energy and also reducing greenhouse gas emissions on farm. Their system is a modular plug-and-play, scalable AD system tailored specifically to suit the needs of the dairy sector. So I'm delighted to introduce Owen, and I'm going to stop sharing, Owen, and allow you to share your screen. So hopefully, yeah, it's just coming up there now.
Excellent. Thank you very much, Seán.
Thanks very much, Owen. Over to you.
Brilliant. So good morning, everybody. I'm Owen, founder and CEO of a company called Biofactory, who have developed a modular AD system specifically for improving slurry management on small and medium scale dairy farms. So just to give a bit of an overview, this presentation is very much UK, or has UK figures in it. I haven't been able to get some time together to pull together the Irish market data yet, but it's an area that we're particularly keen in. We've had a lot of interest from small and medium scale farms in Ireland for exporting our product over to that market. But a bit of an overview as to why farmers would want AD, especially small farmers. We see kind of three key benefits for the farmers that they want out of putting in anaerobic digestion. Main one is energy independence, reducing their outgoings and possibly diversifying their income through selling excess energy to the grid. The second one we're seeing a lot more of is improving resource utilization. So by digesting the slurry, you improve the nitrogen availability for crop uptake. And thirdly is reducing emissions from slurry management. This is a big one for the industry as a whole. However, a lot of our individual farmers are only looking at this as or if it is cost effective. Obviously, a lot of them are keen to reduce their emissions. However, if it doesn't make financial sense, there's no point in investing in a huge piece of infrastructure that won't affect their bottom line and improve it. The other reason is we're seeing a big energy transition in the sector. So we're moving away from human labor and red diesel to the use of electricity on farm, which AD is a perfect source of power for. So that might be robotic milkers, robotic scrapers and feeders, and the introduction of new fuel technologies such as electric farm vehicles and biogas powered tractors. Now, on that side, we see kind of electric vehicles working particularly well for farmyard machinery. However, the larger in-field tractors are probably not going to get to the point where electricity is viable in that sense. So you've got other options like the New Holland biogas powered tractor. There are kind of hydrogen developments as well on that front. We're also seeing a big transition off farm. So from a personal perspective, farmers might be interested in electric vehicles for their own use. Also, we've got kind of CNG off-farm transport for milk, for example, that could be supplied by upgraded biogas. We're focusing on the dairy sector for a number of reasons. One is the availability of slurry in a readily pumpable form that can be digested. The other being that there's a high input energy demand in dairy processing. And so we see that as our kind of beachhead market into the space with our AD product. However, we are particularly interested in processing FYM on, say, beef farms, pig slurry, possibly looking at utilizing the same technology for processing sanitation waste and food waste as well. But to give an idea of what the UK dairy sector looks like, I appreciate the numbers might not be accurate to the Irish market. However, there's probably a good reflection of similar circumstances. So in the UK, a huge amount of manure goes untreated. So the kind of 3/4 of the circle here is produced by the dairy sector, which is not treated at all. It's just held in storage in lagoons and spread to land. There's a huge amount of energy potential in that, which could be a massive benefit to the UK and Irish markets, whether that's through personal use or improving grid reliability and decentralizing power production and improving stability. The other reason we're looking at the dairy sector, and this is quite reflective of the Irish market, I believe, is that a huge amount of that is small to medium scale dairies with less than 500 cows. I think in Ireland, the average herd size is slightly smaller than the UK market. But a huge amount of the manure is generated in that space. So with 100 to 500 cows is kind of the sweet spot that we're looking at for our product. In terms of greenhouse gas emissions, this is the greenhouse gas emissions from manures that could otherwise be processed in the UK. Implementing small, medium scale AD systems could have a significant impact on reducing those emissions. With our particular focus on 100 to 500 cows, you can see that that's a significant portion of the overall emissions that could be reduced. This is, I suppose, the big question for everyone is why isn't AD used on small and medium scale dairy farms? So from all of our conversations, we have whittled it down to about 5 kind of key barriers to entry with traditional AD technologies. And that's why we've kind of approached it with our modular design. The first one being management burden. So often the larger, more traditional AD systems that need energy crops to make them financially viable require one labor person to manage and maintain them. That's quite inefficient for small farms to be able to do. A lot of them won't be able to afford that, and it takes them away from their primary business model of farming, which they like doing and they know how to do very well. So instead of introducing a new technology, we're looking at minimizing that management burden as part of our product offering. Future-proofing the design the system for that farm. So through conversations with these small farms, a lot of them might have a 5-year plan, but if you talk to them about their previous 5-year plans or 10-year plans, the business has changed so much or so quickly that going through a traditional AD system design and installation might lock them into a specific way of operating that is not effective for them in the future. And we've heard stories of farms who've gone through the planning processing, spent however much money on doing that, and realized they might want to grow the herd by a couple of hundred more cows. And therefore their AD system that they've just spent a lot of time and effort designing isn't suitable anymore. Which leads me on to my next point. In the UK specifically, there's a huge amount of cost associated with the planning stages of putting in traditional anaerobic digestion, which isn't effective for small farms. One thing that was surprising to us was the need for small, sleek products that work within the footprint of the farm. James from Cube will talk about their solution, which utilizes existing slurry stores. We've opted for a more kind of high throughput design in a small footprint that minimizes the space that's taken up on the yard. And finally, cost. We all know that AD is quite cost prohibitive. It's a huge investment into infrastructure, and a lot of farms can't access the capital to put into an AD system that might cost £1 million+ and take a long time to pay back. So often that results in systems being designed that are larger than required to process the slurry, that require additional energy crops to generate an income to pay back the initial investment. And they are often seen as distracting from the farm's primary business, which a lot of farms aren't interested in. And so it results in less of a rollout of traditional AD technologies, which we all know here in this meeting is really beneficial for the environment and for the farm, and for the energy security of that business. We see modularity as the easiest way forward, or the best way forward, to enabling AD technology on small, medium scale farms. The reasons for that is that we are able to standardize the production of a modular AD system that can be quickly deployed. They provide an asset to the farm that could be relocated if needed. It could even be sold on into a secondary market, and so it's not a sunk cost into infrastructure development on that site specifically. In the UK, we've been able to simplify our planning and regulatory requirements to meet with simple permitting systems for the Environments Agency. And I don't know if you've got something similar in Ireland, but we're able to deploy our systems under permissible development rights, which is a very simple mechanism for the planning office. With the modularity of the design, we're able to expand and change the product over time to meet the farm's needs. And if there is a problem with the product, whether that's an internal issue or whether the farm, let's say, drives a JCB into the side of it, God forbid, it's never happened, and we hope it never happens, but we can lift our tanks out and replace them very easily and quickly. The other thing about modularity is it allows us to centralize the operation and management of those systems, so the farm doesn't have any additional burden applied to them for implementing a system. That will be completely managed by us, and it allows us to, as a result, prioritize just slurry treatment on the farm to offset existing energy bills. So this is the product that we've developed, which is a containerized modular system. We've been lucky in this deployment to have an old silage clamp that we've been able to fit the product in, but we could fit the system in the green space next to the slurry lagoon here just as easily. Essentially, what the product is made up of is our 40-foot shipping container, which is our digester. It serves about 80 to 100 cows worth of slurry, and we can produce continuous kind of 11 to 15 kilowatts of electricity and about 20 to 25 kilowatts of heat to the farm with that system as it stands there. The way the modularity works, if I can go to the next slide, is essentially we'll add additional shipping containers to match the farm's requirements on energy, processing as much slurry as we need to do that. Typically, we found a payback of anywhere between 3 and 7.5 years, depending on how much of that heat that's being produced can be utilized. So we're often at the lower end of that scale for users that might be pasteurizing their milk, that might be doing other kind of onward processing of the milk, turning it into cheese, where there is an existing high heat demand. Often that existing demand is serviced by electric boilers, and so replacing it with our essentially excess heat that's produced through our CHP, we can significantly offset that cost. Towards the later end of that range would be farms who are pretty energy efficient, who aren't doing any additional kind of processing and can only use a smaller proportion of that heat. One thing that we don't account for in our payback estimates are reducing other farm inputs like fertilizer costs, the cost of maintaining your lagoon, that's minimized through kind of less solids making their way in there, reducing the spreading costs, so reducing the amount of diesel used to transport and spread the slurry. And we think this product is particularly suitable for 100 to 500 cows. However, we have had interest from much larger farms where we can essentially have kind of 6 or 7 of these tanks alongside each other processing all the farm's slurry. I've probably talked about all of this, so I'll just race through. The other thing I haven't mentioned, I suppose, is that the product is essentially a completely plug and play system. So we manage the slurry pumping, the energy production inside our system, and we provide the farm with electricity, heat, and digestate, which they can do with what they want. So there isn't any need for kind of additional pumping systems that might add additional complexity to the farm, or whether they need to source their own CHP to utilize the gas. We don't have any of that. We deal with it all within the confines of the plant. It benefits from a safety perspective, but also we can completely manage the process as well. You can see by this deployment here, we've got a hardcore base, so it's really minimal infrastructure required to put in one of our units. They've got a slurry channel out the back that we chuck a slurry hose into to draw up what we need. And yeah, that's essentially the product that we've developed. We think it's particularly suitable for this sector, and we've had a particular focus on the UK so far, but the Irish market is definitely one that we're interested in exploring. And yeah, if anybody would like to reach out, our contact details are there, and I'm sure you can get copies of the slides.
Thanks very much, Owen, for that presentation. If any of our attendees this morning have questions for Owen, please post them in the Q&A tab at the bottom of the screen, and we'll take them in a few minutes. There are some questions have come in, and we'll address those at that stage as well. So I'm now going to reshare and introduce our next speaker. So our next speaker is James Rundle, Head of Sales at Cube Renewables. So Cube Renewables is committed to turning waste into energy. Their Lagoon Cube technology captures fugitive emissions from slurry lagoons. It's a low-cost, simple solution for dairy and pig farms. It allows the conversion of that methane then into on-site electricity. The company was established in 2012 and has been delivering projects both in the UK, Europe, and across the globe. The Lagoon Cube operates in UK and Spain and are actively seeking partners in Ireland. And we had Cube Renewables present at an event we did back in 2018 when we launched our EIP project first. So we're delighted to welcome back James and Cube Renewables to present here today. So James, can you hear us and see us? Yeah, and you're on screen, absolutely. And we can hear you. So perfect. I'll just go to presentation mode. So it's over to you, James.
Thank you very much, Seán, and thanks to Teresa and also to David. So thanks to the Irish Bioenergy Association and the British Embassy in Dublin. It's really good to get this opportunity to talk to you, to discuss this kind of really important developing technology. Owen's given you a really good background on why this is important in the sector. If you could just move on to the next slide, please.
Yeah.
So a little bit of background on Cube. So we've been going since 2011. We have a series of different technologies, but the key here is, so our first ever contract was to look at trying to process organic waste in a forward operating base. It was a UK military contract. It was awarded to a company called IrBEA Environmental Matters. IrBEA are a environmental consultancy that in the past sort of couple of years have dealt with probably about 5% of the UK renewables projects in terms of planning, permitting, carbon accounting. They came together with a specialist engineering company called LogLogic to deliver this contract. So we effectively designed a containerized solution for organic waste in Afghanistan for the British military. So they were looking at very specific issues around very high fuel costs of around about $200 a litre, and how they're going to get rid of human waste and organic food waste. The reason I'm saying this is that all of our sort of work ethos came out of that. So it was about building robust, efficient, simple systems that could solve problems. So throughout all of the different technologies we've developed since then, it's all about robust, deployable, modular, and cost-effective systems. So that unit was built. That original unit is still going back at our HQ. We have a demo site in West Somerset in the UK. You're all very welcome to come and see us over here and come and have a look. But so from that period, we developed out an enormous amount of experience in AD. So originally it was in large scale AD. As you might be aware, in the UK, this was highly subsidised. So we were doing a lot of very large AD projects. The government cut that support a few years back, but we were already doing small scale systems. So we've also taken on an investment from a large waste management company in Singapore. Again, that's not really relevant to a farm in Ireland, but it is in a way because it's allowed us to develop out this technology. So as Owen kind of alluded to, in the UK, there are challenges on this sort of technology in terms of government policy, government regulations, and also lack of clarity around government support. So this isn't an area we would really be able to be in without the ability and the investment from a company called Blue Planet. So it allows us to develop out and actually trial and make sure that these bits of the kit, we're always at the sort of cutting edge of what we're doing. Next slide, please. So as I said, we've developed out a range of different technologies. Some are very specific to containerized food waste. So, food producers, hotels, hospitals, those types of systems. We've got a system called a Quick Cube that is specifically for humanitarian operations. So our Quick Cube team have just delivered one into the Gambia. So those are really going out into the humanitarian setting. Again, all about modular, but it's sort of in terms of the efficiency of the biogas production and also the use of that biogas is really sort of critical to Cube's value. On the right of that, you've got a green box called a power cube. So those are our own in-house CHP generators. So we buy in and modify diesel engines and then sell those out as biogas engines specifically. So we do all of that modification ourselves. We've found that efficiencies are very challenging at this kind of small scale. So these engines run from anything from sort of 3 to up to 15, 20 kilowatts. Above that, obviously, you can buy in the market. So those that we've developed out, you'll see a couple of pods on the right there. Those are our Lagoon cubes. I'm going to talk a little bit more about those in a minute. And then we've also got a couple of other products. We've got a patented dry digestion technology that we use in agri-waste opportunities over in Southeast Asia. Could you put the next slide on, please? So Lagoon Cube, we've called it Lagoon Cube. It effectively, it's relevant to any storage system, existing storage of slurry. So our target markets are very, very specific to the dairy sector and to the pig producers. So both have huge amounts of slurry, both have sort of increasing issues in terms of government regulation, environmental impact, ammonia emissions. So both we see as sort of overlapping importance. So effectively, we're using existing storage with a floating removable cover, so it will sit on top of that, and we actively manage the gas off the surface. So you're not only collecting biogas, but you're also managing rainwater, which I think in Ireland is really important, as important as the West Country in the UK where we are. So we're putting in a floating cover, so it can, regulation is coming in the UK that says that farmers have to cover existing slurry stores. So that's obviously for ammonia emissions. So the wind draws across a lagoon or a tank, and it draws ammonia out. If you cover it, it minimises that emission. However, it doesn't solve the methane emissions. So that methane will get vented to atmosphere. We put vents in floating covers, and that to us is just sort of madness. The dairy sector particularly, but also the pig producers, are being beaten with a lot of environmental sticks. There's a lot of pressure on them to improve their carbon journey. And by saying you have to cover something and then vent methane to atmosphere, we see that as a madness. So that's why we've developed this out. So we in terms of the floating covers, we do put access points in, because if you just cover a slurry store, depending on the dry matter, depending on if you've got a separator, but that can produce challenges for the farmer in terms of mixing and clumping. So we do put access points in so that the farmer can mix the slurry and reduce, so have less sort of operational problems. We do either pods or full covers. We much prefer full covers, so they're dug around the outside. They are fully compliant with anything that comes out of Europe and the UK in terms of air quality ambitions. So that, I think that's a sort of key thing here. We're all going to be looking at, this is regulation coming in, so these are compliant. But it's mitigate greenhouse gas emissions. We've been through it. Effectively, this biogas, around about 55–60% methane is vented to atmosphere. So all we're doing is managing that and taking it off and using it on farm. Another important factor on this is around water quality and runoff. So all the rainwater coming onto the cover is captured and pumped off. So that's all done by our in-house technology. So these systems are all managed and run remotely. So we put a software system in that will run all of that, and it'll manage the levels on the lagoon. It also, when you've got a floating cover, managing the water is a really good safety operation, so you don't get big bubbles of gas. So what do we do with the biogas? I've showed you our range of CHPs. Effectively, it's up to the farm. So we will not be exporting power using just capturing existing methane from a farm. But what we will be doing is making significant reductions in their imported costs. So that's the sort of key here. We'll either use it in a CHP, which is probably the most efficient method, but we can also put boilers in for hot water generation. So if a farm has a huge amount of hot water generation requirement, then we can put biogas boilers in. Biogas boilers are more efficient, but generally, because of the cost of electricity, the rise in that, it's meant that CHPs are more valuable. And obviously, we'll take heat back off that and use it on the farm. So in terms of the development out of our lagoon cube, as I said, in the UK, this has not been without its challenges. A lot of farmers still to this day are waiting on clarity for regulation and grant support. I think it's a really important point. So we're not suggesting that all of this should be supported by the government in terms of grant subsidy. I think Owen would agree. What we're saying is it's around clarity. So both of our technologies offer a return on investment to the farm. So I'm not saying the government should support it. What the government in the UK should do is tell farmers how they're going to support it. And if they're not, then at least the farmer knows and they can make sensible investment decisions going forward. So we put our first lagoon cover on in Norfolk, in the east of the UK in 2019. I think it'd be fair to say we've all, we've all learned a lot. That was a really challenging. It was a very big lagoon, and since then we've really understood how to actively manage gas and move it off the lagoon. And so up to a current project we're running at the moment, taking gas off a really large lagoon up in North Lincolnshire. So our products developed, our technologies developed, and we've got to a system where we have, we understand what biogas is going to come off and how to actively manage that and be a safe and efficient system. Next slide, please. I'm going to skip that one, actually. I'm going to go on to actually just giving you some examples of how that does. Thank you. So we put together two models here just to sort of demonstrate where this sits in terms of how big the farm is. So as you will all be aware, every single farm is different. You just don't have the same sort of management operations. So a farm could have, numbers are variable, but a farm can have grazing 6 months of the year. They could be in 24/7. The existing slurry storage might be different areas, different tanks, different lagoons. There might be a pit at the back. They might have underfloor stored. So we have to model individual farms specifically. I'm afraid these are in pounds sterling, but there's you just have to add a bit in terms of euros. We'd be really happy to put individual models for dairy farms together, and obviously those will be in euros. So this gives you an idea of one farm in the southwest of the UK. So it's a 220 cow. It's an organic milk supplier, supplies Waitrose. Cows are in 6 months of the year. Because of the weather we're having here at the moment, it's looking like they'll probably be in for about 5 months of the year. We've had incredibly dry spring. So this is based around a rectangular concrete pit that they've had built. I think that's about 10, 11 years old. So we've looked at that. We can cover that. So we've costed up and we've modelled up exactly what the farm's going to get out. Because the cows are out for 6 months of the year, you get less slurry, so we have a less efficient system, so we've got a slightly longer payback. And all these are set for the ambient temperatures in Dorset. So when we model for you, we'll look at those. They'll be fairly similar, but things like rain and temperature will slightly different. Will differ from if you're on the west coast or over on the sort of Dublin side. So, but we'll go through all of that with an individual farm. Going through the numbers, and again, this is in sterling. So we use a supplier for our covers. He's actually based just north of the border. So they're a Northern Irish-based company. They have an office in the south. They'd be really happy to come and quote. So effectively, they are the specialist in covering biogas stores, slurry stores. So we use them. The liner in this instance would cost around about £20,000. Our gas capture system would be around about 75, and then the engine, in this instance, it would be an engine, is around about 25,000. So overall, 120 grand. And this is without any subsidy, obviously, support. So the payback on that, so if you're looking at, and again, we'd take your electricity rate, this is based on a rate of 21p a kilowatt hour. So that's probably, whatever is that, 26 cents a kilowatt hour. So we would just get that local figure to what the farm is paying, would readjust the model, but it probably sits around right. So out of that, a farm will get a potential CO2e saving of around about 400 tonnes a year. And if you look at the overall carbon footprint of a farm of this size, that makes a significant dent on it. And if your buyers are looking for a more sort of carbon friendly producer, it has little value now, but going forwards that will have more and more value. So that's a significant reduction on that. Obviously, you've got the ammonia savings there as well, but we're looking to produce out of our CHP around about £23,000 worth of power. So effectively, and we'll link that CHP generator, so it'll be grid tied, but it'll be completely managed. So when you've got biogas, you'll stop importing. If you've got solar, we'd integrate it with that, so you're not using solar and biogas at the wrong time. So using biogas at night when there's no solar generation is a really sort of efficient way of doing it, and our systems will integrate all of that. So that's that gives you sort of the one view of an opportunity. If I could have the next slide, please. So slightly bigger farm. So this one's in Cornwall. They supply Arla, 450 cows, but they are in 12 months of the year. So they've got a lagoon with around about 2.8 million gallon capacity, so quite big. They have also got the ability to manage that quite well, so we can keep that fairly full. You can see the graph on the bottom there is about the volume of the lagoon and the biogas generation from that, and therefore, how much power and heat you can get off those, get from that. So that's, looking at a GHG saving of around about 1,000 tons a year. Again, significant impact on that overall carbon footprint. And the energy saving at this farm pays 25p a kilowatt hour, so more like sort of 30 up towards 30 cents a kilowatt hour. So that the payback to them annually is around about £62,500 on a total investment of around about 220. So the paybacks on this are really interesting. These are all validated data. We're not waiting for government subsidies to come and drop in. These models, they pay back quite quickly, and they're tried and tested and effective. So that gives you a little bit of an idea about we would generally go from farms of around about sort of 80 plus up to however big you want, really. If it's got an existing slurry store, we'll do it. I've just put a little bit I've just put one slide in around Spain. It sounds a bit random, but Spain has a really well-developed fugitive gas capture support system. So both federal and local. So Catalonia has a massive pig production industry, and it also has a large dairy sector. And slurry is a huge problem there. Around about sort of north of Barcelona, there are a lot of pig producers, and they have big slurry problems. So the government has taken that in hand. So they subsidise, they support sort of biogas renewable energy on farm. So we're a lot more developed there. We're based in West Somerset, and we're doing more in Spain, because there's a joined up policy for that. So that's just a little bit on Spain. We do have a team that can deliver projects. What I would say is I'm lucky enough to travel to Ireland quite a lot. My daughter's at college in Dublin. And so I am there. We are looking for partnerships. So we're looking for people who are keen to either obviously put on farm technology, but we would love to look at some suppliers and partnerships to build it. Obviously, long term, we want to build this under license in Ireland. It doesn't make sense to ship stuff. We would ship a few, but we'd really like to just build that model and have a proper Irish cube base. Thank you for your time. I hope I haven't gone over too much. Please drop us some questions or drop me a message, and would love to meet up with you in Ireland.
Thanks very much, James, and thanks to yourself and also Owen and David and Noel for your presentations and contributions. So before we get into the questions and answers, there's quite a lot of questions have come in, and we will go through them all. Maybe Noel, are you on screen?
I'm not having trouble with the screen, but it's an audio.
We can hear you. Okay. No, just if I come back to you, Noel, while Owen and James are just gathering their thoughts ahead of the questions, and maybe come back again to the EIP Department of Agriculture funded project. You mentioned that there was a lot of farms actually applied to participate in this project, but there was quite a significant amount when you did assessment that weren't suitable from the point of view of the project and developing a biogas plant on their farms. And I suppose the main thing to point out here is that the biogas plant in Galway is more of a conventional biogas plant in that system compared to what Owen and James have outlined. But Noel, just briefly, while the lads are getting their thoughts together on the questions, what were the obstacles, I suppose, for the farms that didn't succeed or weren't viable from the point of view of proceeding to develop a farm-based biogas plant? Because this is not for everyone, it's specifically suited to certain types of farms.
Yeah, well, look, I suppose the detail really where we found differences were what we tend to look for in the most suitable farms was that the ready supply of materials, so slurry, that tended to push towards, like when we see dairy farms moving more towards extended grazing seasons, which obviously has benefits, and you were not looking to change that. But what that done was it lessened the slurry supply and tightened the window on when slurry was available. So that was in some ways a negative for in terms of whether biogas would be suitable. And secondly, the storage system that they had. So, for example, where we seen dairy farms with cubicles and slats, because the slurry storage is directly underneath it, it doesn't offer much opportunity to capture that slurry and digest it. Whereas if they're using scraper systems into overground tanks or lagoons, then it was a much more suitable scenario because you capture fresh slurry and put it through a digester. Now, the sort of systems we're seeing there, obviously, and this is what we taught at the start of the project, and in some ways it was ahead of its time. Um, Technology is going to develop around the farm itself. So the idea of taking the material directly in the lagoon with lagoon covers, we would see as something has got a massive benefit for a lot of those farms that we were not suitable 5 years ago. Definitely a technology like that could be considered. And so it's really, and we did expect that most of the technology developed in biogas over the last 30 years has been more on the large commercial side for food waste, whatever else, because that's where the economics were. Whereas now moving back towards the farm side of it, and that's where the RAISE report is so helpful. It's looking at what suits a farm. And I think we're seeing a lot of innovation, and these are two companies, two examples of that. And we've seen many more through the project that are adopting more for farm rather than the large commercial scale type plant.
Okay, and that probably takes us to the next question, or the first question I'm going to focus on this morning, and it's a question from Daniel. Is there any current farm-based AD opportunities here in Ireland currently? So I could take that maybe just to say that the current biomethane strategy is for medium to large scale plants, but it doesn't preclude, or it didn't preclude the capital grant program, which was announced by the government and administered by the Department of Agriculture for a 20% capital support grant, didn't preclude the development of farm scale plants. So if you were a farmer and you had a plan for a farm scale plant, you could have applied through that capital support mechanism. Obviously, that's closed as of now, but we are expecting that there may be more supports coming in the near future. And I suppose to answer the question, where is it at in Ireland currently? So what we're talking about here are type 9 ABP plants, animal byproducts plants. So there are currently, as I understand it, three actually ABP type 9 plants. The Grange site in Meath, there's a farm in Waterford, and there's the Galway farm now, which is coming on stream and coming live. So so there are examples of this scale across the country. Type 9 animal byproducts plants. So I hope that answers your question, Daniel, about the supports and also about the current numbers in Ireland. Owen, if I could bring you in, there's a couple of questions there for you. One is around the digestate, and the question is from Paul, and thanks, Paul, for joining the webinar this morning. Can you elaborate on how digestate is managed post-process? Is it being used as a fertilizer? And how are issues like nutrient loading and local land spreading constraints being addressed? So,
Yeah.
So that's the first question, I suppose.
Yeah, so in our existing deployments, most of the systems put the digestate back into existing slurry management. So if you imagine you've got a slurry channel that's pre-existing on the farm, we'll draw out of the closest point to the cow shed that we can, and we'll deposit it somewhere further back into that existing infrastructure. In this sense, the digestate's mixed back with the raw slurry that might not be treated, and goes back into an existing slurry lagoon, where it's spread in the same manner that they already spread raw slurry. There is a question around nutrient loading. Obviously, we're improving the readily available nitrogen within the slurry through the digestion. It's increasing by about 50%, so we can spread that slurry thinner across the land bank. And obviously, this is very dependent on the farm itself, but you might end up with having two too much nutrients on the available land bank. If that's the case, that needs to be considered in a individual nutrient plan. For most of the farms we talk to and we've deployed our systems on, that's not been an issue. All of them have used synthetic fertilizers, and we're reducing that consumption of synthetics. There are a few of our clients that have phosphate, particularly over phosphating problems. So in that instance, we would recommend that they put a separator post the digester, and they probably separate their existing slurry availability as well, to remove that phosphate and essentially export the solid portion of that material.
And 50% uplift, you said, is very high. We wouldn't have, we would have always worked on the basis of a 10 to 12 to 15%. So just that's very high if that's what you're getting through your system.
Yeah, that's what we've seen from the systems that we've got so far.
Another question, and it's a couple of questions from Paul here. Are there concerns about contamination? But you're not importing any feedstocks for use in these systems, because they're very specific, using the existing farm feedstock. So contamination isn't an issue, but contamination can be an issue at a large scale if, depending on the types of feedstock that's used, and then effectively affect the digestate. So really, I suppose the answer to that one really is, it depends on the type of feedstocks, but not at your scale that you're talking about in terms of imports. Another one from Paul, again for you, Owen, while I'm with you. What level of maintenance does these systems require? Is that handled by local site staff, or is specialist intervention needed regularly? And is there remote and fault diagnostic monitoring on these modular systems?
Yeah, so similarly to James, we've got a remote operating control system that has been specifically developed for our product. It allows us to monitor our system performance kind of remotely and diagnose any faults. We don't have regular touch points with the systems in the field, which is a good thing in terms of requiring maintenance. So we would do a regular, probably quarterly visit to the site to replace filters and do the regular maintenance practices that we need to keep the plant operational. The only input from the farm that we've had has typically been slurry contamination with foreign objects that need to be removed from pumps, really. But you would get that with any pumping system, I would expect.
Okay, and then warranties as well. What type of warranties apply, both on mechanical equipment and overall systems performance? So you take responsibility for the design, obviously, for the system. So
yeah. So sorry, James, if you want to go first there.
Well, I think it's a question specifically for you, Owen, and then we have James in it as well. Yeah.
So we offer a 2-year warranty on parts, and they'll be replaced if there's any issue within that time. But we also offer a service contract that we would recommend our clients take, so that we manage and maintain the system completely, and that includes a provision for replacement parts and other equipment that needs servicing. In terms of the mechanical parts, our tank doesn't have anything that moves inside it apart from the slurry, so there's no need to get in and replace anything inside. Everything's maintainable from the outside, so it's relatively cost effective. And then in terms of performance, we're quite beholden to the quality of the slurry. So if the quality of the slurry changes over time, it's difficult to get gas out of something that's very wet, for example, or mostly water. So we'll work with the farm to make sure that slurry quality is high. But in terms of the uptime of the system, there'll be warranty provisions around that side of it.
Okay, we'll come back to you in a second, Owen. There's a couple of questions on planning, which I'll come back to you in a second on. James, back to you then. What is the delivery time for a project? And again, is there warranties on your system?
Yeah, so warranty, we would put 1-year warranty on all moving parts. But I mean, there aren't very many. the lifespan of the product that we cover with, so Linton and Robinson from north of the border would put that on. That has a 10-year design life, but I mean, there's examples of that are still existing, and they're well over 10 years. So that's using a product called Nicoflex. So yeah, we would. And in terms of delivery time, I think at the moment, so there was a big grant in the UK for slurry management, and they've just reined that in a bit. Lead time on the covers was going from sort of 5 to about 8 weeks. I think that's come back a bit now, just because the slurry management grant over here has been reduced. So I mean, projects could be designed, delivered, probably done in 2 to 3 months.
And just a question there, and maybe you don't have an answer for it, but maybe you do. How does the cover work out in terms of cost per ton of CO2 removed? Well,
I would defer that one. It also, there are so many variables on this. So if you've got a dry matter content of 5 or 7 or 18, everything changes. So we would just talk to the farmer first, and we'd then put a model together. I just wanted to add one thing to what Owen was saying around about the sort of slurry. I mean, obviously we just use existing slurry. It's part of the slurry management. But in terms of post AD, so once the biogas has been generated, there is really good evidence, as Owen says, just to back that up, of nutrient availability. There's not enough scientific work done on that, unfortunately, and it's something that I think Angela Bywater and that team, I think there's a bit more going on. We're doing a little bit on it as well. It's a really important part of it going forwards, and the sort of anecdotal data is really strong.
Okay, a question then, which probably covers both of you, or for both of you. Curious about the safety of the systems showcased. Are there any specific safety features or safety concerns or safety items that you'd so maybe Owen first and then James?
Yeah, so we fully comply with the DESIR and ATEX regulations. So in the UK it's DESIR. I think in EU it's ATEX derivative. We're working with some external consultants about maintaining that kind of level of safety across the whole product. In most cases, we would recommend that there's a kind of safety barrier that is put outside of the product, so that you don't have people wandering into areas where they might be potentially exposed to biogas. And in a general sense, it's it's a relatively safe product, but because we've got explosive gases being generated, we do need a level of care to make sure that the components don't get damaged, and maintain a good kind of safety level.
Okay, we are at 39 and we're hoping to get finished by 45, so we have a couple of questions. A good few more questions.
Could I just add, sorry, Seán, just
James,
really
I forgot
quickly.
to ask you to come in.
Yeah, just in terms of what we do, so that's the reason we're actively managing the gas off the lagoon. As soon as you start having bubbles on a lagoon under a cover, you've got large explosive bubbles. So we actively manage it off there, and then obviously everything is compliant with it. It's UKEX here, ATEX there, so it's all compliant with the regulations, and we do this a lot.
Okay, then coming back on planning, so I suppose the question for you, and I think you mentioned that there was something about permission development rights for your system. So can you give us an update where it sits from a planning perspective?
So
in the UK,
in the UK, I don't have any data on how it would sit in the Irish planning system, but in the UK we fall under something called permissible development rights. Right. Which is essentially the lowest rung on the planning ladder, which allows you to essentially notify the planning office that you're planning to do this, and provided that you follow a relatively kind of wide set of requirements, then you're allowed to do that without kind of going through a bespoke application, essentially.
Okay. And I suppose just there's a second question on planning as well, and the question is it exempt? So you kind of covered that. It has from an Irish perspective, just what we would say as the Irish Bioenergy Association is that each a farmer should consult with their planning consultant to to check whether it is exempt or not. I suppose there is an exemption in Ireland for certain size of development, but there are a number of parameters associated with that, like proximity to other householders and neighbours and various other things. So it's very hard to say it is or it isn't exempt until you know, because each individual's situation and circumstance is different. But certainly, I think your system on would fall under the 200 square meter threshold. However, it's down to individual circumstances and situations. James, do you want to come in on that then in terms of planning for yours?
Yeah, so we're really lucky. As I said right at the beginning of this, we're part of an environmental consultancy. So we came out of one. They have an office in Ireland. A lot of their work is around agricultural planning and permitting. So generally, there's some permitting or planning needed when you cover a lagoon. And effectively, we're fitting into that. And then use of gas on farm is another thing that would have to be looked at. And again, the team are looking at that, about how what the regulations are around use of gas on farm.
Okay, and thanks very much, James. There's a couple of questions here more specific to Ireland and specific to larger scale, which I'm just going to quickly take. Timothy, thanks for joining in your questions. Any update on the RHO? So I suppose the renewable heat obligation, for people that don't know, is the mechanism by which they're using or hoping to use to develop a large scale industry here by driving demand, putting an obligation on fossil fuel suppliers. The latest is that it hasn't been launched or published. We have had a lot of engagements with the department in the last number of weeks and months, and they're currently in an approval process, or going to embark on an approval process at a European level. So again, if you want to ring me, Timothy, I'm happy to give you a further update. There's also you had a question in about the biomethane capital grant. Has that been transferred to the Department of Energy? So my understanding is that the current grant scheme is being administered by the Department of Agriculture, but that the Department of Environment, Energy and Climate are taking the next phase in terms of its mobilisation and rollout. When that will come, we don't know. It is talked about for next year, but it will move from the Department of Agriculture to the Department of Energy, Climate and Communications for the next round, as we understand it. And is there plans to delay the final date of completion of AD plans to qualify for the grant? So current plans that have a letter of offer have to have their project completed by the end of the year. We have engaged on this with the department. It has been confirmed that an extension isn't possible. However, we'll continue to engage and to see what's possible in that regard. Going down through the last questions, and maybe this is one for, I don't know, either of you lads. Are the UK dairy farmers being awarded by milk processors for reduced methane or CO2 on farms at the moment?
Well, so very quickly, there's one big buyer that has started that journey. They're further down the line, which is Arla, but they're still, all the sort of environmental criteria are quite complex, and it's a changing picture, but it is happening.
Okay, and Noel, one for you. Could we get the panel's view on the role of slurry additives?
Yeah, I'm just reading that. So in terms of additives that are there to preserve, to basically retain the methane within the slurry for a period of time, it's a tool that might be of benefit, because it allows you to store slurry and store the methane is not released immediately. Normally slurry is trying to release the methane immediately. But what's interesting, say for example, in the lagoon example there where it showed the figures, we see all the slurry obviously going in the winter, but most of the methane being released during the summer. So it might be possible to push out that more into the autumn time, or to level off the peak a little bit. So the additives are another tool. I think they are an advantage to biogas plants, because they do also allow you to take slurry from an external, from that's underground, that's stored underneath cattle, and use that in a plant without and maintaining the level of methane in it.
Okay, Owen and James, a yes and no answer. Do you see them as a threat or a potential enhancement to your offering? Slurry additive.
Neither.
Sorry?
I haven't really seen the data in terms of efficiency.
Okay, and Owen?
Need to see that.
I'm the same.
You haven't looked at them. Okay,
No.
that's fine. A question from Emer. Any human sludge processing with some slurry import food waste sites? So again, we're very specifically talking this morning about farm-based, which is just slurry, waste silage, animal feedstock available on the farm. Certainly from the medium to large scale biogas, biomethane plants, human sludge is currently being processed. And also food waste is being processed. So again, not relevant to James or Owen in the context of
Well,
the systems.
but I would add it just adds a level of required pasteurization. You know, in terms of
Exactly, at a farm level, which isn't economically viable
yeah.
at that scale. So yeah. Owen, did you want to come in?
I was going to say exactly the same. You've got to
Okay.
make sure all the waste processed is pasteurized at that point.
Yeah.
And it's a
Can
big
digester be
cost.
dried and pelletized? It can be dried. That's a cost that probably isn't bearable at a farm scale level. It can be pelletized, but you know, so again, it's at a medium to large scale more so than a farm scale. Owen, do you want to come in on that?
Yeah, we've been working on some interesting projects around green bedding. I don't know what the regulatory position is in Ireland, but we've got a lot of waste heat that is often unutilized, drying and then separating, then drying the solids of the digestate, and then using that for green bedding is quite an interesting proposition.
Yeah, and it's something that could be explored here, but I understand that it's not really being utilized, but it is an option. James, had you anything then about the digestate being dried and pelletized? Probably.
Yeah, no, it's all about cost. So I mean, one day, as Owen alluded to, if we can bag up phosphate as well, happy days. But it's all around cost benefit. If you can make that system work, it's great.
Couple of more questions. I'm just going to throw them at you quickly. Permitting for small scale projects. How hard is it to get it? So I suppose in Ireland the permitting requirement is an animal byproducts requirement, more so that there's no waste permits or anything like that required at the farm scale. So you just have to engage with the department and go through the process. In the UK, is it the same, Owen and James, from your perspective around permitting?
Yeah, there is a waste permit that we need to comply with. It's called T24. It's essentially we're processing on farm slurry using AD, but as long as there aren't any other additives to that.
Okay. Is a gas question from an anonymous attendee? Is a gas line or gas boiler specialist required to maintain the AD system from the generator to the boiler, from the AD plant to the boiler?
Not sure what that means.
So in Ireland, we have a register of gas installers. So if you're putting in any sort of gas installation, you have to be a registered installer. We would recommend that they should be a registered installer in the context of this as well.
100%.
Yeah. Okay. Do you see methane reductions becoming compliancy driven by the EPA at farm scale level? Again, maybe more specific to the Ireland from the and probably we could have a webinar itself on this topic. So I don't know if you have any comment or want to comment on that. So do you see methane reduction becoming compliancy driven by the EPA? Well, I suppose just from an Irish perspective, there is no certain farms do have an EPA license depending on the type of farm they are. So those farms obviously have compliance requirements in terms of fulfilling that license, whatever the requirements of the license are. But the vast majority of no dairy farms, in my understanding, has an EPA license or livestock beef or sheep farms. But some of the more intensive agricultural sites would. So it would all depend on the specific requirements of each license on farm. As things develop, do you see farmers being paid for slurry as a feedstock for communal AD sites becoming possible? So again, it's not at this scale, but potentially. You want to comment? Come in.
There's some examples of what we call hub and spoke AD systems. Slurry, because it's such a low calorific value in terms of AD sense, often those models don't really work from a cost perspective. But there are a few examples we can link to if you like.
So I think that takes us to the end of the questions. I think I've covered all the questions. We had quite a significant amount of questions. So I suppose in summary, from my perspective, and I give James and Owen and maybe David and Noel a chance just to say literally a concluding remark. But from my remark, it's, you know, farm scale is very viable. It needs quite a significant capital grant. It's not for everyone. And there are various different technology options available, and we've been presented with a number of those technology options this morning. So James first, then Owen, do you want to have any, what's your concluding remarks, James?
Just, we're really interested in the market. Please get in touch. Let's start a conversation and let's model up individual farms.
Owen?
Yeah, I would say exactly the same. We're just to clarify on my presentation, perhaps it wasn't clear, but we don't require grants to make this financially viable. If they are there and the support of the sector really helps kind of facilitate those, but yeah, it's not something that requires grants.
It wouldn't be the IrBEA line really. From our work in terms of the EIP, we would the plans and we've looked at would require 50% capital grant. But look, everyone has their own business case and their own figures, and that's all good.
I mean, grants would be great.
Yeah,
yeah, grants are good.
It would help. It would help
so
everything.
Noel, concluding remark.
Yeah, I mean, it's
briefly.
compared to 5 or 8, 9 years ago when we started looking at this. Now the technology offering is much wider, and I think it now suits a far greater number of farms. It's obviously not for every farm, but the number, as the technology is adapting more and more, it's becoming a tool that I think we're going to see a lot more rollout on farms over the next number of years.
Okay.
But I suppose the energy supply and in nutrient management. So.
Okay, and then David, we give you the concluding remark. So
Thanks.
do you want to say?
Yeah, thanks very much, Seán. Thanks to Owen and James for coming along and everyone for attending. And I think just my takeaways is that, you know, it's very clear that there's some uncertainty still around the policy landscape and the challenges that exist. But just from the sheer amount of questions and the amount of interest, there's huge potential here. The technology exists, the interest is clearly there, and there's really a willingness to collaborate. So in my opinion, and as an embassy, we're keen to see this not as the final stage in something, but as the first stage. So this should be a first step, and I'd be really interested in doing more, building these relationships and understanding kind of what we need to do to get these things built and get these things happening in Ireland, because I've been working on this sector now for about 3 years, and the longer I'm here, it's more fascinating and interesting, and it's just that excitement and potential building, and I'd like to see things happening. So yeah, thanks very much again, Seán, and everybody for coming.
Yeah, thanks very much to Teresa as well, who helped to organize today's webinar. And finally, just to thank our speakers, thanks James, thanks Owen, thanks Noel, and thanks David. And again, we're very appreciative of the collaboration with the British Embassy Dublin for this webinar. Recordings will be available in a couple of days, and if anyone has any questions, please feel free to get in touch with any of us. All our contact information was displayed earlier. Thank you. We'll leave it at that. Bye-bye.